All right, friends, I want you to get your notebooks and pencils. We're going to turn to our next clean sheet, which is 17, and we're going to title it Thermal Labs. So go ahead and title page 17, Thermal Labs. Okay, so at your table, you have a baggie and yours has an ice cube in it. Mine doesn't have it in there yet. So today's challenge is going to be for you to melt the ice cube without taking it out of the baggie, and you have 1 to 2 minutes. So I'm going to set the timer and you have 1 to 2 minutes. Before you start, I want you to talk to your group and discuss a way to accomplish this task. So come up with a way to do it, and then you have 1 to 2 minutes to melt the ice. Go. Okay, so now I want you to answer these questions with your group members. So I want you to pause the video so that these questions stay on the screen as you discuss them. I'm going to give you a few minutes for that, and then I'll tell you what we're going to do next. All right, so you should have discovered that the longer the ice was in contact with warm matter, something that was warm, the faster the ice cube melted. So heat transfers from warm matter to cold. So you might say that the ice cube changed from a solid to a liquid because of that heat, okay? And we're going to be talking about this for the next couple days. Okay, so I'm going to be doing a demonstration here. And before we get started, I want you to write on page 17, prediction, because you're going to make a prediction. So write that word and then I'll tell you what you're going to predict. All right, for your prediction, you don't have to write these questions. You're just writing the answer. So I want you to predict what is needed to make a solid water, like ice, change to liquid water and water vapor. So what is needed to change water vapor back to liquid water and ice? So I'm going from ice to liquid to water vapor, and then water vapor back to liquid, back to ice. So make your prediction of what is needed on page 17. You're not writing the question, you're just writing your prediction right here. Go ahead and do that now. Okay, so while I'm doing the demonstration, you're going to be putting notes in this chart. So I want you to pause and copy down this chart. So you have the color of cube, clear, blue, green, yellow, red. You have the start, which is going to be our starting temperature, which I will tell you for each one. And then after 2 minutes and 4 minutes, we're going to write down the temperature, and then we might go 6 and further. So we'll just have to see. So go ahead and copy this down. Okay, so here I have a blue cube, the red ice cube, the yellow ice cube, the clear ice cube, and the green ice cube. And now I'm going to tell you the starting temperature of each one so we can put it in our chart. Okay, so because each one is starting as ice, water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. So they're all starting frozen at 32 degrees Fahrenheit, 0 degrees Celsius. So go ahead and put that in there, and I'm going to start the timer for 2 minutes. Okay, so here I have the timer set for 2 minutes. So I'm going to start it, and we're going to see what temperature they're at 2 minutes. Okay, so the 2 minute timer went off. When looking at the clear thermometer, I am at 25 degrees Fahrenheit and 1 degree Celsius, and it's starting to turn into a liquid. Sorry, I bumped it on accident again. My red one, also turning into a liquid, is the same thing, 25 degrees Fahrenheit, negative 1 degree Celsius, because on the thermometer, you'll see I'm at negative numbers. It goes negative up. It's backwards, I know. You're okay. The green, also becoming a liquid in the big old bag, is also, so they're probably all going to be very close to the same thing because they're all spending the same amount of time in the bag. So see, the blue is becoming liquid, same temperature, yellow becoming liquid, same temperature. So have those written down for 2 minutes, and I'm going to start 2 more minutes, so that'll be the 4-minute timer. Okay, so now when looking at the green, we're all liquid. Same with the clear. Same with the yellow. Ooh, picking on my desk. Same with the red. And same with the blue. Now their temperature, if I check their thermometers, I checked and they were sitting at 39 degrees Fahrenheit, 4 degrees Celsius. So that's at the 4-minute mark. So I had my 2 minutes, so you need to fill in the 4 minutes for each one. Go ahead and do that now. Now your chart should be completely filled out. Mine is not, and that's fine. Underneath, I want you to write the word questions and answers because I want you to answer these 2 questions. The first one is, at what temperature was the water in its solid state? So go back and look at your chart. What temperature was the water in a solid state? Use a complete sentence to answer that. And then number 2, what was added to the solid state or the ice to cause it to change state? So think about that and what we did in our groups. So answer those 2 questions. Okay, so for this next part, I took all the liquid from the baggies and I put it all together in the beaker with the thermometer. So it's all in there. That's why it looks like a funky color. Okay, so now what I'm going to do is I'm going to take this over to the hot plate, which you can see right over there, and I'm going to put it on the hot plate and we're going to watch what happens. Okay, so it's on the hot plate starting to heat up because remember the hot plate adds heat. So it's sitting there right now. We're just going to keep watching. Okay, I'm going to get in closer on the beaker because I'm starting to see what looks like fog and bubbles on the beaker, which hopefully you can see that too. See how it's no longer clear and glassy? And I'm going to check the thermometer real quick to see what temperature we are at because we're going to need that information. Okay, we're at 55 degrees Celsius, 125 for Fahrenheit, and we are rising quickly. If you can see, we got some steam. We have lots of condensation, and we're starting to bubble. Okay, so the water is starting to bubble. There's lots of condensation and vapor. We are at 100 degrees Celsius, 212 Fahrenheit. So remember those numbers. We're going to need those later. Okay, so in your notebook, in the question answer section, we're going to write this. The temperature of the water as it began to evaporate was blank. So we're going to put that in our journal. What was the temperature? If you need to, go back and listen to what I said in the video. What is this state of matter occurring? So think of states of matter. Look in your notebook as to what the states of matter are or over on the wall. And let's answer that question. Okay, so I know these look like a lot of questions, but what I want you to do is I want you to answer these questions with your table group from what I just showed you. And you're going to answer them with your table group because then you can discuss. And so you have a better understanding. Then I want you to write a brief reflection at the bottom of your notebook on page 17 in your question answer section. So you don't have to write the questions. You're just coming up with a reflection over all of it. And then we're going to discuss this when we take our notes. Go ahead and have that finished and fill out your table of contents. Okay, so if I keep letting the hot plate go, eventually the water is going to completely what? Evaporate. So what would be left in the bottom of the beaker? Talk to your group about it. Okay, we're going to turn the page to page 18. We're going to title it Boiling, Freezing, Melting Points. And we're going to copy down this anchor chart to help us remember. So I have my thermometer. It shows where the boiling point is, where the freezing melting point is for water. And this is in Celsius. So copy this down on page 18 and then you are good to go.